All right, good evening, good morning, depending on in which time zone you are. Um, my name is Kees Profstra. I'm responsible for marketing at MultiLane. Welcome to our webinar. The name of the webinar is Thunderbird, a new era in bit error rate testing. So Thunderbird is the new user interface for all our BERT platforms. So why are we devoting a webinar to a user interface for a BERT? You know, BERTs are very powerful instruments. They can also be very complicated. And using one of these powerful instruments is something seen as a challenge. So we completely revamped the user interface with three elements in mind. So first of all, it needs to have a user-friendly, intuitive workflow. It needs to have quick responsiveness, so you push a button, right away things are changing. In addition, it should enable very advanced analysis. The things, signal integrity, you know, the high-speed IOs that we're working with these days are challenging. You need a very powerful tool to be able to do that. So that's exactly what we're going to talk about today. And I'll start with a brief introduction. Just a little bit of logistics for the call today. If you have a question, please use the Q&A chat box in your menu bar. We are keeping track of the questions. If we can, we'll answer it right away. And otherwise, we'll just wait till the end and we're going to review the questions as a group. And number two, you know, we've put everybody on mute. You know, we have a little bit of a crowd, and obviously that will avoid some background noises. All right, so with that, I'll just start with the introduction. Let me just go here. So for the folks on the call who do not know MultiLane so well, so what we do is we provide test instrumentation, just like Anritsu, Keysight, and Tektronix, but we offer it typically at a little bit different price point. So we have the same, you know, performance and functionality to be able to work on your ultra high speed interfaces, but they come at a much more affordable price point. In addition, you know, MultiLane has a very broad solution portfolio. We just do not have only instrument boxes. We also have interconnects. We have software solutions, compliance test solutions. So it's a very broad solution portfolio. We currently have, you know, thousands of instruments deployed worldwide for multiple years. So we have a pretty big install base all around the world. You'll typically see our black and blue. That's a new color scheme of MultiLane. We used to have a production testing focus, but these days we also see that we are being used more and more in R&D and development activities. So our solutions are high value solutions. Again, they're leading edge technology, addressing the latest IO speeds, have the functionality that you need to have to be able to do your work, but at a more affordable price point. You know, we are not going to sell you a multi-channel 112 gigabits per second BERT that runs at around 400 or 500K. So makes things a little bit easier from a procurement point of view. Oops, sorry. So just to give a little bit of an overview of the products and solutions that we have. So on the left, you see a bunch of our products. So we have a lot of BERTs in different form factors. So we have BERTs focused on manufacturing with a disposable interface, BERTs that are focused on R&D, or like a host emulator, you can plug a transceiver in directly. You know, we have optical switch boxes that have optical switches, VOAs, power monitors integrated, you know, for testing optical transceivers. We have an oscilloscope platform, optical as well as electrical. And of course, we have a very broad portfolio of MSA compliant interconnects. And we'll talk a little bit more about it as well. So we also have solutions. So we have a complete transceiver test solution. We can look at CMOS compliance, or we have a host testing solution that you can validate and troubleshoot the ports of your host system. We also provide high-speed test modules for Advantage 93000 ATE tester, for testing ultra-high-speed ICs and so on in an ATE environment. In addition, we also have a fully automated DEC cable test solution and thermal solutions to test transceivers over a wide range of temperatures. So I have a little bit of a problem with the button here, unfortunately. Give me 1 second. So for interconnects, we basically support all the key MSAs, from all the CFP variants to the SFPs, SFP-DD, the QSFP, DDs, 400, 800G, OSFP. So we're tracking basically all the key standards that you see in data center interconnects. We support module compliance boards to be able to test transceiver modules, host compliance boards that you can plug into your host system, your switch, so that you can have access to the high-speed I/O interface, and also loopbacks and thermal loads, for testing, the thermal characteristics of your system, and also, power loading your system as part of engineering or as part of an installation setup. So the physical layer testing that we do ranges from the typical jitter and eye diagrams, waveform captures on our DSO platform, or we do like S parameter measurements like insertion loss, return loss, and impedance profiles with our TDR system. And we have also a wide range of BER analysis capability. Like you see here, a pre and post-fac BER analysis or BER bar-top curve, as you see on the left. So a very wide range of physical layer test solutions that we provide in our instrument portfolio. So what do we see in the market today? So 400G is really going to full deployment the second half of this year, of 2021. So you really need to have volume test solutions for that technology. And 800G is kind of around the corner. A lot of people start to think about it. People are starting some developments. We see people ask for interconnects to be able to test transceivers or systems. And also people are looking for BERTs to start testing these interfaces. So the BERT is going to play a very pivotal role in these technology cycles, like a 400G volume manufacturing BERT and an 800G R&D BERT. So very important to have the right BERT to be able to support these development activities. And with that comes, of course, the need of a very powerful user interface. So that's exactly what we're talking about today. So this is Thunderbird, the new user interface for all our BERTs going forward. So with that leads us, it's a very nice lead into our live demo. And Hani Dao has a bunch of equipment in the lab, and he's going to run through Thunderbird and showing how easy to use it is, and also showing some of the very powerful analysis capabilities. So with that, I will transfer to you, Hani.
Thank you very much, Kees. Thanks for giving that overview and being a great master of ceremony as always. Good morning, good afternoon, as we like to say in this global industry of ours. Thank you for joining us. As Kees mentioned, today we are going to talk about ThunderBERT, our brand new industry-leading bit error rate testing software platform. And with that, I'm going to go ahead and share my screen, and we're going to jump straight into it. Now, on the left, you will see the hardware setup one out of two, the first hardware setup that we're going to show you guys today. This is our 4039E platform, and it is going to be in full electrical loopback with RF cables. Now, the 4039E has 4 channels, each one capable of 58 gigabaud. Now in PAM4, that is a full 400 gig electrical link, exactly really what the industry is using to bring 400 gig, 800 gig designs to market. And on the subject of 400 gig and 800 gig designs, we're all here for the same reason, more or less, the same purpose, if you will. We need to bring cutting edge, fast designs to the network environment that are affordable, as efficient as possible in terms of power consumption, and obviously fast enough to handle the growing bandwidth requirements of the cloud industry, of AI, of ML, of all of that stuff. And what we're learning right now in 400 gig and especially 800 gig is that the trade-off between power consumption and bit error rate performance is the dominant narrative of our industry as we really push the envelope of how much power we can cool in a port and how much power our mutual customers, the hyperscalers, the big guys, want to pay in terms of, multiplying something like this over 1,000 or even 10,000 or 100,000 ports, because any sort of power optimization or any sort of BER, bit error rate optimization, really makes a difference for them and for all of us subsequently. And we're going to talk about how our Thunderbird platform allows everybody from the vendors to the sellers to the consumers of these modules and any sort of device under test, how this GUI allows you to balance that trade-off between optimal performance and optimal power consumption. So with that, I'm going to jump straight in. You can see right now, I've actually got the Thunderbird icon over here. And the first key factor that we are going to be showing off is speed. Just like that, I typed in my static IP address, and lo and behold, I am already right in the GUI where I need to be. Now, you'll see over here, we have a very comprehensive sort of configuration window that we're going to walk through. We've got a method to kind of configure our 4 transmit signals right here. You'll see everything is super responsive to the touch, and we have our receive signals over here. Now, as you can see, everything is really, really responsive. This is where I can kind of configure my output signal, and I'm going to go ahead here actually, and I'm going to change my baud rate. Now I see on the chat we have some power users of the legacy GUI. I know you guys are really going to appreciate this. Setting a line rate is basically instant now. Gone are the days of waiting, a long time, multiple seconds for your bit rate to load. Now, just as fast as 1 second, I can type in my bit error rate, and I have immediately a link on the RX side. We'll show you some of the ways that you can configure your transmit and receive side. So as you can see, I have an on icon that I can toggle off for any transmitter. You'll see I turned off my TX1, and because TX1 is connected to RX1 and loopback, I lost lock right over here. I'll switch it back on, and I'll get my lock back almost instantly. I can go ahead and change the PRBS signal. Right now, I have PRBS 13Q going transmitted on all the receivers, but I changed that to PRBS 7 on the transmitter, and you'll see my PRBS 31Q receiver has lost lock. I'll switch that back to PRBS 31, and I'm right back where I was before. Now, talking about power consumption, we have our equalizer set to the most power hungry setting, which is kind of setting the equalizer in the transmitter to the full blast, if you will. Our BERT has either an optimal transmit mode where you can just set your output amplitude, a 3-tap transmitter mode, or a 7-tap transmitter mode where we use a 7-tap transmit equalizer to give you very, very fine control over the transmit signal. So not only can we use that 7-tap transmitter to give you the cleanest signal possible, we can also use it to corrupt the signal. And what I mean by that is channel emulation. I can go ahead and set any amount of dB loss I want in my channel. I can type it in here and select it, and it will actually set that amount of loss in the transmitter to emulate, let's say, a lossy electrical trace or a coupon board. But for my demo for setup 1, I'm going to stick in 3 taps mode. Now, Again, what I told you guys as I set up a bit error rate test is I configured these transmitters to operate at around, let's say 1E minus 12 with full blast, putting the taps on the maximum power consumption possible. And as you see, as I take a look at the details tab, we are in fact running error-free on all 4 channels. And that's great. But the thing is, we're not in the business of optimizing alone. We need to figure out how can we enable you guys to say, yes, my DUT works with the cleanest signal, but does my DUT work with a less power hungry signal that is more realistic of the production environment? Now, what I'm going to do is I'm going to load a configuration where I have my transmitters in a more efficient mode, which will naturally result in a high bit error rate. And this is where I really get to show off the graphical capability of Thunderbird. I'm going to select what I want as my x-axis and what I want as my y-axis. I can select as many measurements as I like. I'm going to select the channels I want to view. And remember, I'm expecting a high bit error rate now because that's what I configured for my transmitters. I'll hop into one of these transmit equalizers and you'll see the main tap, which is what drives the amount of signal power, has been lowered so that we can emulate a high bit error rate environment. Now, you'll see right away, there's a lot going on in these graphs. I can decide to add or remove any measurements at once, and it doesn't make a difference to my details tab, because my details tab, regardless of what I want to show on the graph, is tracking everything. Now, let's say I open the details tab right here on the right, and I see, okay, there's a lot of information, that's great, but I only care about a few data points. I only care about, let's say, time, real-time BER, instant BER, instant error counts, and accumulated error counts. Now, why are these measurements important? We're going to talk about that in 1 second. So, jumping in here, you set up a test, okay? Everything's going as expected. You see your real-time BER is around 20 minus 6. Okay, that's fine. It's coffee time. You go, you drink your coffee, you take a 5-minute break, okay? You come back, and let's say we can emulate an error burst. This is where our error injection feature comes into play. We are going to inject a bunch of errors on the LSB portion of the signal of TX1, just like that, just for a couple of seconds to drive my point home. And then I will turn off the errors. So I came back from my coffee break and I see, wow, some error burst happened on channel 1. Now, what do we offer with Thunderbird to allow you to track the error behavior of your DUT? Well, we have introduced history navigation. I'm going to enable history navigation on the right here. And I am going to kind of use this cursor to be able to see at any point in the test, what was the instantaneous value of any measurement. Now, to really drive the point home, what we're doing here is we're acquiring the instant error statistics every 100 milliseconds. That's 10 times a second, and we are stringing it together. So any measurement offered in Thunderbird can be captured in both real-time or instant modes. Real-time being cumulative, instant being in that 100 millisecond time constant, what was the error profile? And error bursts require this type of advanced error tracking. These error bursts, like the one that we forced, are the difference between a strong transceiver design and a marginal transceiver design. And we are giving this visibility to be able to diagnose transceiver marginality, both to the vendors and the consumers of these high-speed products. So I'm going to jump in here, and I'm going to use my cursor to say, okay, looks like at 92.4 seconds, okay, I'm looking and I'm seeing my bit error rate at channel 1 was still pretty normal. Now let's take a closer look what happened later. 93.3, okay, as you can see, the real time, the instant BR is still E minus 6. But if I jump over to 93.6, you'll see, wow, that instant BR is now 4 E minus 3 because of my continuous error injection. So I'm going to go at different points in the history navigator, and you can see, you can, at any point in the test, you have the visibility to get exactly what was happening at that moment. Something we have not offered in any of our software before that we're very excited to offer now. And then you can see, you remember, at around 100 seconds, I turned off the error injection. So at that point, the instant BR becomes better because I'm no longer injecting those errors, but the real-time BR reflects the whole story up till that point. The 1E minus 6 plus the error injection, and then removing the error injection again.
Hey, Hani, can I just interject just quickly? Hey guys, for everybody on the call, if you have a question, please use the Q&A button and post your question. We'll get to your question either right away, or we'll answer the question at the end of the presentation. But that's a good way to communicate it. So please don't be shy, and there must be a couple of questions. Just use that bar. All right. Thank you.
Thank you for reminding us, Kees. Yes, we really want to get your thoughts and questions. We've got myself and some colleagues are online to answer them in real time, or we can answer them live. And another thing, just before I forget two things, we will also be sending out a survey to all of you guys. We would really appreciate it if you could take a look at that survey and maybe give us some of your thoughts so that we can continue a successful webinar series. And that's really our intention here. So jumping right back into it, we talked about what we can do in terms of tap configuration, error injection on the transmit side. But what we have not talked about are the RX diagnostic capabilities. So right now, I just popped up a pop-up menu of the RX channel. And right now, immediately you'll see, I can go ahead and I can invert a signal and I will lose lock. I can uninvert it as well, and I will get locked back. We also have multiple diagnostic measures. Our BERT, we designed it to have automatic FFE taps so that at any time your signal is being equalized and optimized, and because that's really exactly what's going to be happening to your DUTs when they're out in the network, because that's what host systems are going to be designed to do. But it doesn't stop there. We also offer real-time signal-to-noise ratio of each channel. You can check that out, and you can see the SNR. Right now, it's not so good. It's actually at around 20 dB because, again, I lowered that main equalizer. And another thing I can show you is the histogram. So I'll go ahead and I'll update the histogram, and now you're seeing those 4 logical levels of the PAM4 signal. And basically, these are really handy tools to use when, let's say, you need to get a sanity check, a check to make sure, is my signal good? Is my SNR good? My histogram, if anything's going wrong with your DUT. We also support additional equalization. And this is really one of those things, one of those value adds that is really unique to MultiLane, in that how much we can present with the BERT. So we can add real DFE, reflection canceller, level dependent equalizer, or even a multipath interference canceller to be able to emulate different equalization, or not even emulate, to be able to replicate different equalization techniques that your DUT will be able to leverage out there in the field. So right now, we showed you guys everything about real-time and instantaneous measurements, and we talked about why error bursts are so critical to be able to track. But that is not the full story. We have designed these, we as an industry, we have designed these pluggables to transmit high error rates just by design. The limits of physics gave us no other choice, so we had to adapt. The way we adapted was by introducing forward error correction. Now, FEC, it's a tried and true technology that's been around for a long time, but this is the first time it becomes a mandatory encoding mechanism for data center interconnects, for optics that are meant to be, not going across cities, across oceans, but, shorter reaches, still within a campus, a data center campus. To be able to give our customers full visibility on FEC behavior, we have implemented real hardware-based Reed-Solomon IEEE compliant forward error correction in our flagship BERTs. And applying that FEC is as simple as going into the FEC tab and pressing apply. Now you'll see I actually only have one RX lock indicator. And the reason is that by choosing 400 gig KP FEC, we have taken all 4 channels and we have squeezed them into one link. And that is really how FEC works in real life. That those code words that are built up by the FEC encoding scheme are stripped, or rather striped, across all 4 channels to create one link. Now, let's test that out. We also have 100 gig FEC and 200 gig FEC. We can get into that a bit later. Each different BERT we have offers different sort of FEC encoding mechanisms. So now we're going to go ahead and repeat our steps by not this time showing the pre-FEC statistics, but we're going to show the post-FEC statistics. We have a really wide variety of measurements that are related to FEC performance that you can read more about with our FEC white paper, which is on our website, and I'm sure we can send that out later. So what I'm doing right now is I'm adding a bunch of measurements that are going to look a bit chaotic, but we will simplify the story right away. So now you can see something's going on over here. Now, what really is going on? We can open our details tab and we can actually check out the most critical FEC parameters. And you know what, for now, we'll just stick to the corrected code word count, instant and accumulated. And we'll check out the instant uncorrected code word count. So we're going to check out all the code words that were processed that we were able to save, and the ones we were not able to save. So accumulated corrected code words, accumulated uncorrected code words, just like that. Now I turn off filter, and you can see, if you zoom in your screen a bit, you can see that we have a instant corrected code word count, which is climbing up. And we also have an accumulated corrected code word count climbing up, but we still haven't created any uncorrectable code words, which we can do. So I'm going to keep only one measurement here just to show you guys something, and that's going to be accumulated corrected code word count. Now, the rate of corrected code words, seems to be about, let's say, 100,000 per second, or maybe a bit less. But if we go ahead and inject errors on the FEC link, you'll see that rate will shoot up, because suddenly the FEC encoding mechanism is correcting a much higher rate of code words. Now, the most critical reason that we have introduced FEC, besides the fact that the industry simply requires it, is that we want to give our users and customers true visibility into the margin of their FEC performance, as if to say, all right, I've got a DUT and it's working fine. How close am I to a failing condition? Because remember, those error bursts, which sometimes are a byproduct of designs that go into these transceivers, are the difference between making a link and breaking a link. And to be able to give you a full depiction of that marginality, we have an SER measurement, a symbol error rate measurement. And by the way, these are the same measurements, the same sort of visibility that you would get in, let's say, a 400 gig or an 800 gig switch, simply because they are the key figures of merit for a healthy link. And in fact, I will take it a step further to say we have more measurement visibility than the switches do, simply because this is our primary focus. So a quick note about SER and symbol errors in general. When a traffic stream is encoded with FEC, with FEC, every 10 bits, this is an oversimplification, but that's okay. Every 10 bits are transformed into a symbol. And then for KP4 FEC, which is the kind of FEC that we're using today, every 544 symbols, which is 5,440 bits, becomes a code word, a FEC block. Our symbol error rate histogram, which is what I'm showing right here, is a depiction of every single code word, how many symbol errors is it getting. With KP4 FEC, remember, the highest number of symbol errors that you can correct per code word are 15. So just even with the aggressive error counts, even with lowering the magnitude of the tap equalization that we have implemented here, we are still operating with a bunch of margin. You can kind of see as I zoom in here, we actually have some code words with 8 SER, but with 8 symbol errors, some code words with 7, some with 6. But as expected, there is a big drop off between, let's say, low SER and high SER, because the signal, in fact, prefect bit error rate can be up to around 2 times 10 to the minus 4 before the post-fect bit error rate becomes uncorrectable. So with our SER, with our real-time corrected bit counts, corrected code word, and uncorrected code word counts, we have full hardware FEC, which we are proud to introduce to the market effective today. Now, I will take a second actually to jump over to some of the live questions. We, in fact, do not have a Mac client today. This simply is a result of some of the market feedback that we've been getting. This would definitely be reconsidered if we had more customers who were very interested in who are more interested in being able to work on Macs. Today, I would say, a Windows virtual machine will do just fine. Now, we've had a few other questions. I'm going to take a look and just try to answer in time. Another question about Mac. It will work not natively on Mac OS, but any virtual machine like a Windows Parallels, like running a server on a Mac Mini, a Windows-based would work. But we do not immediately have that solution natively on Mac today. So let's see. How do we know the FEC margin in the GUI? So the FEC margin that we are offering you guys is really the same sort of visibility you'll get in a real life network switch. And now the idea here is that we're giving you the SER, and the SER is really the indicator of FEC margin, because it's basically telling you, okay, I am not showing any code words with 15 symbol errors or 14 symbol errors or 13 symbol errors. And from that data, you can understand, okay, I can withstand a worse BR or a more degraded SNR. So our margin is translated directly to the SER and the code word count. Now, we've had another question. I believe this was related to the exporting of data. So we have a fully developed API, which is going to be released next month, which is going to be really as fast and as efficient to automate as the GUI is. And yes, you will be able to have that timestamp associated with any data you extrapolate. We will also plan on including detailed test reports in the GUI itself. However, this is still on the roadmap. It's not yet ready from our software team. Let's see. Now, another question was, what's the ref clock here? The ref clock is, in fact, right now 156 megahertz, but that is only really relevant for the clock out, which is actually, you know what, that's a very good segue into our next demo, which is going to be a different setup. So I'm going to stop this guy. I'm going to switch over to a different setup altogether, in which we can talk a bit more about the ref clock. So setup number 2 actually introduces a sampling scope. This is what it looks like right now. We have a 4039EN, which is our same BERT, except it has noise injection. This BERT features a really, really valuable feature, which allows you to introduce either random or burst interference noise, which is kind of mated with the transmit signal of the BERT, and it's completely asynchronous and completely configurable so that you can emulate real life crosstalk conditions. Now, again, to close on that question, 156.5 megahertz, which is, I believe, data rate divided by 200 or 300, is going to our 50 gigahertz electrical sampling scope, which is going to be used just to show you guys what that eye diagram looks like when I go from no noise to lots of noise. So I'm going to jump right into there, and you'll see now I have another Thunderbird tab with a different static IP, punch it in, and just like that, super quick, we're back in action. Now, what my kind of setup is this channel, TX2, is connected to my scope, and TX1 is in fact connected in loopback to my receiver RX1. Now you'll notice the user interface is just about the same, except we have that N, which stands for noise, and will allow you now in the transmit window to inject noise on a digital scale from, let's say, 0 to 1000, if you will. And you could also do it from a burst perspective. And the burst noise really comes in periodic bursts where we're basically setting a pattern on the noise source. And it's completely asynchronous. So really what you're doing here is you're unlocking the capability not only to test the noise, the resistance to noise and interference of optics or modules, but to test the same thing on hosts. So noise injection is the bedrock of our host testing solutions narrative. And if anybody is more interested about testing the host side and some of the testing that we've done with our 400 gig switch, which is in the room next to me, I'm happy to talk about that. Really quick though, just to drive the point home of how exciting this noise injection capability is, you'll see our eye diagram here. Now this is not a optimized eye diagram. This is just to really show you visually what happens when we inject noise. This is running not at 53 gigabaud, but at 26 gigabaud. And again, that ref clock is going to be 156.25. And right now, just in real time, you guys are going to be able to see what happens to that signal when I start to crank the noise up little by little. And you can see now the y-axes, those logical levels, are becoming harder to discern, harder to tell apart. And I can even crank it up to the full blast, so to a full 1000 point scale. And you'll see that the eye is very, very degraded. Now, that's what noise injection looks like on the scope side. I'll turn it off and you'll get back to that clean 26 gigabaud PAM4 eye. Now, one last thing I want to show you is what does that noise look like on the error detector side. So I'm going to go ahead and do what I did before. I'm going to start a bit error rate test. We're at 26 gigabaud now. And you know what? I will go to 53.125 gigabaud just to drive the point home. Just like that, again, super fast. So I'm going to turn on channel 1, start my real-time BER test. And okay, according to my tap setting, I'm running at about 1 E-10 BER. Let's see what happens when I inject that noise again. Now I've got noise on the digital scale to be around 500. And you can see every time I crank up that noise dial, we have a boost or a jump in the actual bit error rate. And in fact, now you can actually see the noise is so bad that my receiver is flickering. Now let's take a closer look at that. I'm going to go into RX diagnostics and I'm going to look at the signal to noise ratio. And it's a mess, right? It's barely even tracking. And my histogram also is indiscernible. Let's dial the noise back a bit so we can get a lock and show you what the histogram looks like with noise. Now I will update it again. And now you see, compared to that last signal, the logic levels are a bit thicker. So that diagnostic feature really comes in handy. We will finally turn on 100 gig KP1 FEC on our first line transmitter. And we will go ahead and we will run the SER just to show you how increasing the noise reflects in that FEC margin, going back to that question. So I almost maxed out my noise here, and you can see now that the SER includes code words with 5 symbol errors, with 6 symbol errors. I can even take it a step further, inject some bitwise error injection just to, you know, drive the signal crazy. I'll go ahead and auto scale. And now you can see it's barely even keeping lock with symbol errors exceeding 6 symbol errors per code word. Now, that is really all I had planned for Thunderbird today. And I'm thinking right now we can go ahead and switch to some questions and answers. So we got another question. Is the noise is time domain noise, not voltage noise? It is, you know, I want to be a bit selective how I answer this question because, you know, there's a lot of proprietary innovation that went into this. But essentially, you can imagine this noise behavior to emulate a real life, let's say, switch or host, where you have one electrical channel with one chip source, and that is affected by the crosstalk of an adjacent circuit with an adjacent chip, and the signals are linked together in a way. So hopefully that answers your question without selling the farm, if you will. We'll take a look at some of the other questions that we have. Shuang has also been, you know, helping us out and answering some of these questions in real time. And another question we had is there any visual feedback to the multi-lane instrument when we connect the IP address? In fact, there is not, but stay tuned. That's all I can say for now. What do you say, Case? Yeah, more to come. Lots more to come, of course.
All right. Well, Hani, thank you very much for this excellent demo. And you know, I just want to kind of summarize what we've seen here. So obviously, this is very, very powerful equipment. You know, this is running 28 gigabaud PAM4, 53 gigabaud PAM4, multi-channels. And you've seen how easy to use it is. The workflow is incredibly intuitive. You kind of know exactly where you need to go without, you know, digging multiple levels deep where you can find the setting. The second thing is it's very quick. Every time Hani touched the menu, it actually changed right away. There was no thinking. There was no delay. I mean, I know it sounds silly, but that's nice because if you work and you have to wait and it takes long, it's very frustrating. So this is really very quick and responsive. And then number three is, you know, these are small boxes. You know, they're if you see them, but look at the advanced analysis that is packed in there, and all the things that Hani just showed. I mean, this is really pretty spectacular. You know, all the plotting, just selecting of the measurements, you know, adding the fact to it, pre and post fact. So very, very powerful and advanced analysis packed into this new user interface. So very well done, Hani, showing that. I think it's very, very impressive. So maybe we can have a couple of more questions. I think there's a few more questions coming in.
Right.
If you want to answer those.
Sure, I can handle those actually. So what I can start with is I can answer the confidence level question, and we'll get Shuang in to answer the second one, just so he can say hi to everybody. So how can we integrate a confidence level calculation into our report? Well, it's very easy. Confidence level is simply a distribution function, which, you know, anybody can punch into Excel, and that's something that we can consider as an official feature that really would not be hard to implement here. Now, one note on confidence level calculation. It's a great figure of merit. It is more of a figure of merit that is relevant to end users of these modules, as opposed to vendors, producers, chip component manufacturers. So we can do it very easily. We can, let's say at the end of every test, you have a bit error rate confidence calculator. And that, essentially what that does is it sees what is your bit rate, what is your time duration, what is your number of errors, and then what is your target bit error rate. And then it takes in all that information and tells you if your target bit error rate is, let's say, 1 to the minus 10, you have a X% confidence to forever stay 1 to the minus 10 with your current error profile. So great question. If you would like to reach out to me on a personal note, we'll save our emails in the end and we can talk more about your requirements and maybe integrating that feature into Thunderbird.
Very good. And Chung, do you want to take the other question?
Sure. Sorry, guys. Yeah, so, for the customer that using our B, D, and E BERT, we can do the upgrade for you. Basically, we can remotely update the firmware for you first, and then provide you the Thunderbird software. So the Thunderbird software, we're including the 4039B, our new 4054B, the 39D, the 4-channel, and the 79D, as well as the 39E and the EN. And also coming up soon, we will have the 800 gig BERT. This will be 8 by 100 gig, the 4079E, and the Thunderbird software is also available. One note about the eBERT is that we have the real fact that you can buy a little, pay a little small for the license, and also on the 4054B. So that we have the real hardware effect, and that will require a little license for the fact.
Yeah, exactly. So right now, for the new versions of the BERTs that have the real hardware effect, that is kind of an upgrade option that we can quote, but that's only for the new products.
And I would actually like to add another comment, which I think is very relevant to everybody. Something that was really critical to us when developing the software product is one GUI for all of our BERTs, one software experience, one API, one set of functions, one set of enumerations, one instinct to navigate everything in one file for a very wide and diverse family of BERTs. And we've made that happen today.
Absolutely. And I think that's very important because, if you're used to one, if you're used to a certain user interface and you have to transition to a different one, that's always complicated. So for us to have it across all BERT platforms, is ideal from a customer usability point of view. And we're going to do that for our other platforms as well in the near future. So with that, it seems that we have answered all the questions.
Looks like we've got one more, actually.
Is there another question?
That's one for me, I think.
Oh, yeah.
So the question is, do we have a service which takes the transceiver and does all the possible tests and qualification of it without bias to any vendor? That is, in fact, a great opportunity to talk about our compliance test services, which we can link to you in this question. I think one of my colleagues can do that, or I can pull it up real quick. But in summary, yes, this is a bedrock. This is one of the bedrock services that we offer. We offer some types of services that are more system related, like testing it in a switch, interoperability out of our Fremont office here. And we do a lot of the IEEE focused testing. And we've been doing this for a while with our compliance team in Lebanon. So hopefully that answers your question. I will go ahead and see if I can add a link to that answer. Looks like Shuang already took care of it. Thank you, Shuang. And I think we'll wait to see. I don't know if any other questions are going to come in.
So if there's no more questions, I would like to thank everybody for attending. It's always difficult to get out of your normal routine and listen to a presentation, but I think it was very useful. I hope it was very useful for everybody. There's going to be a follow-up Zoom email, and if you could please take your time to fill out the survey, that will help us better understand your test requirements, so that we can focus more on your testing needs. And if you can see here, I shared a slide so you see the folks that were on the call. So Hani Dow on the left, one of our senior FAEs, with his email address, hani@multilaneinc.com. Chung was in the background answering some questions, and he spoke up a little bit as well. Also one of our senior FAEs, and his email is chung@multilaneinc.com. And myself, Kees Propstra, I'm responsible for marketing at KES@multilaneinc.com. So please reach out to us if you want to have a follow-up conversation. We can set up a meeting or a private live demo or things like that. So we always do that. We like to work with you guys, and please reach out to us if you have any more follow-up questions. So with that, I think we can conclude the webinar. Thanks everybody for joining in.
Thank you
Thanks,
all.
Hani and Chung.
Yep.
We
Thank you,
will.
everyone.
Thanks, everybody. We will stick around for a couple more minutes in case anybody has any questions that they want to ask. Please feel free to use this time. We will be available until the questions stop.
Oh, yeah, and just to add, so we are going to send out the recording and also the slides that we showed and a link to the FAQ white paper. So that will be as follow-up from our side. So you can look at that in your free time. All right. I don't see any more questions come in.
We see a hand raised, but we can't hear you.
Yeah.
Hi.
Hi, Chiti.
All right.
All right, everybody.
Anything we missed, happy to answer over email, folks. Thank you so much for your time and for tuning in today.
Thank you, everybody. And have a nice day. Have a nice evening.
Thanks, folks.
All right.
Thank you all. Take care.
Thanks, everybody.
Bye-bye.
Bye-bye.